Hello everyone. Today I am going to talk about the problem subordinates, which is listed in the CSES problem set under the tree algorithms part. So here basically the structure of the company is given, and we have to calculate for each employee the number of their subordinates. Here the input is actually given as a tree for each employee. Their direct boss in the company is given, and we have to print an integers for every employee. We have to actually print the number of subordinates here, and the constant of n is less than is equals to 2 into 10 to the power 5. So what is given to us is actually a tree, and for each employee, and I am considering an employee as a node. For each employee we have to actually print the number of subordinates. So if we take this employee, and the number of subordinates for this employee is actually 2, right? So if I take the example input 1123, that means for 1 2 3, uh 2 and 3. Okay. 4. The direct bus of 4 is 2, and the direct bus of 5 is 3. So here the number of subordinates for 4 is actually 0. The number of subordinates for 2 is 1. The number of subordinates for 1 is 4. Right? So if you actually see that we have to just actually print the subtree size minus 1 for each node. By subtree size, I mean, if we take, for example, if we take this subtree, then the number of nodes in this subtree is the subtree size of 3, right? So if I take another example, for example, for this tree, for this node, the subtree size is actually the number of nodes in this subtree. So the answer is 5 here. Now, to calculate the subtree size, we have to know the subtree size, or to calculate the subtree size of a particular node, we have to know the subtree size of the children of this particular node, right? So, if I somehow calculate the subtree size of these children and the subtree size of these children, then I can easily calculate the subtree size of this node, which is 3 plus 1 plus 1. 3 is from this child, 1 is from this child, and another one, which is the node itself. It is also included in the subtree, right? So basically, we have to actually run a DFS from the root, and for every node, we have to actually take the summation of the subtree size of every child of that node, and we have to also add an 1 to the subtree size, so that we take care of the node itself. So moving on to the coding, um, using namespace cd main, we have to take the number of employees at first. Then for each employee from 2 to n, we have to take the direct boss. And for a graph, we can maintain a vector of integers, and maximum n is 2e5. And for each employee, we have to calculate the subtree size here. So I am actually calculating the subtree size in this array, and for every direct boss, uh, I have to take the child here. Now to calculate the subtree size, I have to call the DFS here. In the DFS, um, in the DFS, this is the current node that I am processing, and this is the parent of this node, right? So for the current node, for every child of the current node, if the child is not is equals to parent, then I am calling the DFS on that child, right? Now whenever I am calculating, I am here for a particular node, I have to actually initialize the subtree size of that node as 1, because the number of nodes in the subtree of that node, the this that the current node will also include in the subtree size, right? The current node will also include in the subtree size. So I am taking care of that here, and I will also add the subtree size of all the child of the current node. So I am actually taking care of that here. Here I am adding the subtree size for all the childs here, and by the end of the DFS I'll have all the subtree size of all node of the tree. Now I just have to print the subtree size of all node minus 1. Why minus 1? Because I have to actually here print I have to actually here print the number of subordinates. So the number of subordinates for 3, for example, for 3 is actually 1, because 3 itself is not a subordinate of 3. So the number of subordinate is actually the number of subtree size minus 1. Okay, now um, let me run this code first, and take the sample input is 41100, 41100. So let me submit the code. Submit uh, C++ file code. Submit the code here. Yes, accepted. So in this problem, actually we just have to calculate the subtree size here, and it is actually a very common problem for trees. And this kind of technique to calculate the subtree size will is actually very important and very tricky whenever we are solving any tree problems. And for this problem, the time complexity here is actually order of v plus e. It is actually the time complexity of the DFS, where v is the number of vertex and e is the number of edges, and the space complexity is actually the number of elements of the array, which is actually here is order of n. So the time complexity is order of v plus e, and the space complexity is order of n here. And this problem is actually very tricky for solving other tree problems, and oftentimes you will find such tree problems for such tree problems that you have to actually calculate the subtree size. Thank you.